Now, let's look at the next topic in this chapter. So we have here confidence interval. So we have this so-called student's T, which is a statistical tool used most frequently to express confidence intervals and to compare results from different experiments. So this is a tool that you could use to evaluate the probability that your red blood cell count will be found in a certain range in normal days. Okay? So if you have this confidence interval, it is an expression stating that the true mean is likely to lie within a certain distance from the measured mean. Okay? Now, if we're going to look at the meaning of the confidence interval, if we are to repeat uh, the number of measurements many times to compute the mean and the standard deviation, so we can have the 95% confidence interval would include the true population mean, okay, whose value we do not know in 95% of the sets of the n measurement. So we say somewhat imprecisely that we are 95% confident that the true mean lies within the confidence interval. So if we're going to look at the equation that you use for this one, so this is the true mean plus or minus TS over N. Okay, so T here, that's your student T, so it's a table you have. Esther, that's your standard deviation, and is the number of measurements, and X is the uh, mean on the set of measurements. So let's try to have an example how to get the confidence interval. Okay, so the carbohydrate content of a glycoprotein is 12.6, 11.9, 13.0, 12.7, and 12.5 of carbohydrate per 100 milligram. So find the 50% and 90% confidence interval for the carbohydrate content. So what does it mean? You get the mean, the standard deviation. Now you can already put here the n as what? 2, 3, 4, 5. And P will be obtained from a table like this one. Okay, so how are we going to select the value of T here? Because as you could see here, there is degrees of freedom and not the number of the sample. Okay, so what does this degree of freedom means? What's the meaning of this degree of freedom? Now, if we're going to define what degree of freedom is, so this is in statistics, right? That's the number of observation minus the number of parameters estimated from the observation. So how many observations do we have? 5. Okay, and then we subtract it with number of parameters. We only have 1 parameters. So the degree of freedom that we have here is 4. So we're going to use this and this in the calculation. So what we're going to do first, okay, we're going to get the corresponding mean and standard deviation. So by now, you should be able to know how to do it. Okay, so I'm going to give it to you the right answer already. So you will have here around 12 point, I would say 54. So it should be 12.5, but we want to include the next digit that we have there. So plus or minus. So you have the, if you follow this formula here, so we have the value of the 0.741. Okay, and times the standard deviation, you will get around 0.40. And then, oh, that is equals to 5 number. And now for the 90%, it's still 12.54, but the value in this numerator will change. So you have there 2.132 and then 0.40. That's the standard deviation divided by. So if you're going to look the answer there, it will be 12.54. And then you have here plus or minus. So this is around 0.13 and this is around 0.38. So what can you say? The confidence interval that you have is higher, okay, at the higher percentage. So this means the higher the confidence interval, the percentage of confidence interval, the wider is the range of values where the true mean may lie. Okay, the same thing if the lower is the confidence interval, the narrower is the range of value where the true values may lie. So this is one way to use this so-called t-test. So this is a t-test. And you use it also for other calculation. One of them is just confidence interval. So how are we going to interpret what we have? So if you're going to look at this, the 50% confidence interval, this is a 50% chance that the true value lies within this interval. Compare it to the 90% chance interval that we have here. Okay? Now, how are we going to improve the 90% confidence interval for vector? How are we going to narrow them? So this is an example wherein they compare the 90% confidence interval for 5 measurements and for 21 measurements. So as you could see here, you can make the range narrower, or in other words, you can reduce the uncertainty by making more measurements. So if we make 21 measurements and have the same mean and standard deviation, okay? So what does this mean is, it's going to reduce the thing. So remember, how does this formula look like? S plus minus TS over N. So we have the same value here, we have the same value here, we have the same value here. What's the one that's changing? This one. So as this number increases, what would be the resulting range? Okay, so as this increases, this whole value here will become lower. Okay,